Okay guys, in this video we're going to take a look at solving a side-side angle case triangle, or as we sometimes refer to them, the angle side-side case, just because this is a pretty big red flag that this might be an instance where we get no solutions, two solutions, one solution. So we are going to solve this triangle, indicate whether the given measurement results in no triangle, one triangle, or two triangles, and then solve resulting triangle, rounding our answer to the nearest tenth. And one thing I want to point out here is actually we're going to do this in the reverse order. We're actually going to solve the triangle first and then state how many answers that we get, one, two, or none. So in this particular case, I kind of don't hide the secret that we're looking at the zero solutions case, but what I want to do is kind of get you into this, like how I might go about solving this. And the neat thing about solving any side-side angle case is that you just go solve it like you normally would. So that is to say, I would write A, B, C. We got the measure of angle A, the measure of angle B, the measure of angle C. All these best practices that we've been doing, we're going to keep doing them. So that is to say, I'm going to write down that I know that this is 3, I know that A is 24, and I know that B is a 96-degree angle. So very first thing I recognize is that we definitely have a side angle pair, meaning that we can use the law of sines here, and that the very first thing I'm going to be looking for here is the measure of angle A. And so what I want to do is just go ahead and set this up. We're going to write the sine of A over the side length opposite, 24, is equal to the sine of B, which is the sine of 96 degrees, over the length of its side opposite here. And so looking at this, running our cross product here, we get 3 times the sine of A equals 24 times the sine of 96. Now, that being said, our plan here is to get sine by itself and then undo it with an inverse sine so that we can get back to the angle. So by dividing both sides by our 3 here, we get our sine isolated, and then our next move is going to be to take the sine inverse of both sides. So we could say beyond a doubt that A is the sine inverse of this quantity here, 24 sine 96. And this is all over 3. So as I've done in the past, I kind of like to get this inner quantity and then take the sine inverse of it. So that's what I'm going to do here. So I'll turn my calculator on, and I'll start with, in parentheses, I'll do the top, 24 times the sine of 96. And I already checked to make sure I was in degrees, but I get this value here. I'm going to divide this by 3. And what we're going to do is take the sine inverse of my, and we got to hit second negative key to get that answer command out here. But we do this, and what you get is a domain error. And actually, I'm going to click on Go To. And the reason why, actually, let's do this again, because I had typed all these in before. I want you guys to see this. When I did the sine, there we go, and we divided that by 3. This number right here, if we're doing the sine inverse of this, then we should have a number between -1 and 1 that we're asking an angle for. But this number is clearly bigger than 1, so we're not going to get any angle that gives us a sine value bigger than 1. So when we write this, we would say, first of all, DNE. And that's just kind of quick for does not exist, because whenever you get a domain error like this, if you haven't made any mistakes in your calculation, then in the side-side angle case, it is because that there are absolutely 0 triangles that could have been found. Now, really quickly, I want to point something out to you here, like how could I recognize this to begin with before I even started? And one thing I want you to recognize is, at least in the last video here, we talked about this ambiguous case here, where this is kind of our setup here. And what I want you to recognize is that we were comparing everything to this imaginary height that we cast down, and that height was, remember, B sine A. In other words, the side adjacent to the angle times the sine of that angle. And what I can see up here is that the side adjacent my angle must have been this lowercase a, because the B would have been opposite my angle here. What I'm going to do is I'm going to tell you that I get H is 24 times the sine of my given angle, 96 degrees. And what I'm going to do is I'm going to figure out a number here. We got 24 sine 96. 24 sine 96. And what I want you to see is this, that the height of our triangle would have been 23.8-ish. Now, the only reason I mention this, units, if this inches, feet, whatever, is because A, when you look at A, or B in this case, is just so much shorter than our height that there's no possible way we could have made a triangle in the first place. And so going back and looking at our cases here, we're saying that the side opposite our given angle was less than that height value that we just found, so there must be no possible cases. Easy way to determine this, though, go solve it like you normally do, and if you get a domain error, it's because you have no solutions. Cheers.